Okay, so hello everyone. Today I am Deswi and I'm going to present to you about my team topic, which is kinematics. So here I am bringing a very unique way of presenting. So I'm not using irregular videos or presentation or anything like that. So what I'm doing is that I have these full screen of flashcard, this is a pre-built flashcard, which means I'm not making this. This is from other people. This is from a website called Quizlet, and I'm here is to annotate this website. And this is all about purely flashcard based. This is going to be a very fun way of presenting this. Okay, so let's jump right in. So we got kinematics. So in this term, we got this keyword, which is what is kinematics? So when you actually click on it, boom, it shows the definition. So kinematic is the study of how things move. So how things moving. So as you can see from here, we got this little images that you can see. So kinematics is very closely related to distance, speed, acceleration. So that you can see the graph yourself. So distance, speed, and acceleration. Now we moving on to the next term, which is speed. What is speed? Speed is something that we kind of uses in our daily life. For example, when we are riding a motorcycle to campus, in a motorcycle there's like a speed calculation on it. For example, you're riding a motorcycle in 40 kilometers per hour. It was written on that. So as you can see, we click on it. Okay, so speed. Speed is the distance of an object travels per unit of time. So this is the equation. So this is the concept. Average speed is equals to distance traveled divided by time of travel. There we go. And then we can move on to the next term. Okay, so we're having an art app break, but never mind. This is the velocity. What is velocity actually? You can click. This is it. Displacement per unit time. So velocity is the displacement per unit time. So this is the distance and this is the time. So that's how it is. That's how you calculate velocity. And you can move on to the next term. Displacement. So displacement, what is actually displacement? So displacement is the distance and direction of an object change in position from the starting point. So for example, point A is the starting point and point B is the finish point. So how you're going to make displacement is having this alternative route rather than have to travel through distance. Like for example, like this. So displacement is taking a very quick alternative route. That's just how it is. Okay, we can moving on to distance. What is distance? Is it the same as displacement? You can see this. Okay, so distance is the length of a path between 2 points. So for example, this guy is trying to reach his home. So the length of a path between 2 points is called distance. Now we can move on to acceleration. What is accelerations? So acceleration is a change in velocity divided by the time it takes for the change to occur. So it was this equation. As you can see, sometimes acceleration could take about 10 or 9.8 depending. So keep that in mind. Okay, moving on to scalar quantity. What is scalar? There's scalar and there's vector. What is the difference? So scalar is the quantity that can be described by magnitude only and has no direction. Meanwhile, vector has a direction, and this is the scalar example. You can see time has no direction, mass too, temperature also. Okay, we can moving on to the vector quantity. Vector quantity is quantity that has both magnitude and direction. So that's just how it is. It has direction, so this is the key point. Having a direction is vector. It is. Now we go to Suvat equations. So Suvat equation is equations to use with uniform acceleration. Position time graph. So this is a graph with time data on the horizontal axis and position data on the vertical axis. So as you can see, this is slowly going up. That is the relation. Position time graph. So there is velocity time graph. This is the graph that has velocity plotted on the vertical axis and time plotted on the horizontal axis. This velocity and time. And then there's horizontal line on the position time graph means the object stood still for some time. So this is the time and this is the position. So it stands still. It has this kind of linear horizontal line that interchangeable. A steady increasing line on the position time graph means the object moved at a constant. So the previous one was like this, linear horizontal, but this one is constant, which means that it will only slowly going up with constant way and not changing like that. Horizontal line on the velocity time graph means this is moving at a constant velocity and acceleration 0. The slope of a line on the velocity time graph gives you an object acceleration. So this is a constant of acceleration. So acceleration is closely related to velocity and time. The slope of a line on the position line time graph gives you an object velocity. So as you can see, it's slowly constant going up. There's a lot of constant now in this slide. The unit for speed. The unit for speed is like the metric, but not the metric. It's like the unit. The international, I guess, the international unit, which is meters per second, it's for the unit for speed. Okay, we have an ad break, but it's okay. The unit for velocity, as you can see, velocity is a vector, which means they have a direction. So it was meter per second plus direction. The unit for acceleration, it was meter per times meter per seconds quadrat, which is meter per second squared. And then if something starts from rest, what is it? Initial velocity. So it was 0 because it was something start from the rest. And then if something moves at a constant velocity, what is its acceleration? It's 0. It's 0 meter per second squared. So I guess that's just how it is. I guess. Oh wait. Ta-da! Congratulations! You guys passed this test. Not passed this test.